Okay, so the question says, the cost of mailing a letter first class in the United States is 45 cents for the first ounce. Each additional ounce or fraction of an ounce costs an additional 20 cents. So if it just weighs 1 ounce, you're just paying the 45 cents, right? If it weighs more than that, then you're paying 45 cents for the first ounce and 20 cents for each additional ounce or fraction of an ounce. So it could be 0.1 ounces and you're going to pay a whole 20 cents for that, okay? According to what the problem says. So the first question says, write an equation to represent the total cost to mail a first class letter that weighs in ounces. So to find the total cost, we know it's 45 cents for the first ounce. Oh, I'm sorry. Unfreeze. 45 cents for the first ounce plus, would you just write 0.20 in? Probably a lot of you did. But 0.20 in means 20 cents per ounce plus 45 cents. We already paid 45 cents for the first ounce, so are you going to pay another 45 cents? Are you going to pay another 20 cents for the first ounce that you already paid for? And no. So you're going to pay 20 cents for, you already paid for the weight of the first ounce, so you have times n but minus 1 because you already paid for the first ounce. Know what I'm saying? So if n, a first class letter that weighs n ounces, so however many ounces minus 1, 20 cents for each one of those because you already paid 45 cents for the first ounce. Does that make sense? Yes. Okay. Number 2. Now, number 2 is a little tricky as well. How much does it cost to mail a letter that weighs 3.2 ounces? Now, I know what you're going to want to do because it's what I wanted to do as well. You're going to want to substitute 3.2 for n, all right? But because partial ounces gets charged the whole amount, you're going to round that up to 4 ounces. So you wouldn't always round in a problem. It just depends on how the problem, how the information is presented to you, okay? So we have, let's write our function that we made. So the cost is 45 cents plus 20 cents for, we already paid for 1 ounce. We have to pay for the cost of 4 ounces because we rounded up. So instead of putting 3.2 minus 1, it'll be 4 minus 1. So we know we'll simplify inside those parentheses first. 4 minus 1 is 3. Now, do we do 45 cents plus 20 cents, or do we do 20 cents times 3? What? 20 cents times 3 is what? 60 cents. And then we can add those together, and we get $1.05. Yay.
I had 25.
Because you charged her additional for that other ounce she already paid for. Am I right? Okay. Number 3, how much does a letter weigh if it costs $1.85 to mail? So are we going to substitute in $1.85 for n this time? No. What do we substituted in for? C, because it's telling us the cost and it wants to know the weight. So I will substitute $1.85 for cost. Now I could do this a couple different ways. Me personally, I would, like the book goes ahead and subtracts 45 cents from both sides. I'm not going to do that. I'm going to go ahead and get rid of my parentheses by distributing. So 20 cents times n is 0.20 n, or you could say 0.2 n, same thing. Is your name on it? Yeah, just put it over there. And then 20 cents times -1, what's that? Y'all got a calculator? Negative what?
Good day.
So 20 cents times -1. I didn't hear what you said. Sorry.
It smells like chili in here.
I know why.
I don't like it. It smells good, but
Hmm.
I don't like it.
So on the right side, I do have like terms. I can combine 45 cents minus 20 cents is what? 25 cents. And I can't combine it with the 0.20 n because they're not like terms. Now what would I do? You know it. So on the right side, I still have 0.20 n. On the left side, 1.60. Now what do I do? N equals 8. So the question said, how much does a letter weigh if it costs $1.85 to mail? And N represents the weight in ounces, so the letter will weigh 8 ounces. What's wrong? Because this time we were solving for N, right? Oh, the must weigh. You're right. You could have told me. The letter must weigh 8 ounces. The must weigh. Miss Rayleigh, nice to meet you. You may have a question on that? What? Do we have to take it home? Yeah. Am I still writing? Can I move on? All right. Page 14. If you need to review how to solve equations, which I think some of you do because when I gave this to you before and just thought that you knew how to do it, there was a lot of hemming and hawing and complaining about that. So if you need a review, come back and read these key concepts when it comes to solving equations. I'm going to be doing a couple examples with you today, and we have worked on it since, but on page 15, so we want to solve the equation. We're solving for x, right? You can see we've got variables on the left and variables on the right. Before we start moving things from one side to the other, on the left side, do I have any like terms that I can combine? On the right side, do I have any like terms that I can combine? No. If you can, do that. I like to do that first before I start moving stuff around. Okay, so I could do like 4 different things here. Me personally, I like to get my variables. I like to move those first, and then I move the constants. You don't have to. You can move the constants and then move the variables. Up to you. And I like my variables to be positive. So if I was going to move a variable and I wanted it to be positive, what would I do first? I'd move the 2. How am I going to move it? What? Subtract it. Because if I want 2x to turn into 0 on the right, 2x, if I add 2x, that's going to make it 4x. I don't want to double it. I want it to go away. So I have to subtract 2x from both sides. So on the left side, combining like terms, 5x minus 2x is 3x. The plus 9, I'm just going to drop it like it's hot. Equals, on the right side, 2x minus 2x is 0. And do I bring down 36 or negative 36? Negative 36. Now what? Subtract 9 from both sides. So on the left side, I have 3x. Positive 9, negative 9 makes 0. What is negative 36 minus 9? We are getting so good. Now what? And x equals negative 15. And of course, you could substitute back up into your problem to check your answer. So if I did, I would have 5 times negative 15. See if this calculator will hold up on me.
Are we doing the examples 4 and 3 and 4 too?
Plus 9 is negative 66. Let's see if that adds up to equal the right side. So on the right side, I have 2 times negative 15 is negative 30. Minus 36 is negative 66. Both sides equal negative 66, so I must have done it correctly. Anybody have questions about that? Coolio. Example 2. Solve the equation 7x plus 4 equals negative 9x. Do I have any like terms on the left side or the right side that I can combine before I start moving stuff around? No. Now, I just told you I like to get my x's together first, but I like to keep them positive. Not that you have to. I just like to. So if I move this 9x over here, I've moved everything to the left and I have 0 on the right. I can do that, but then I'm just going to have to take more work. So in this case, even though I like to keep x positive, it's just going to cause me more work. So I'll just move it to the right and it'll be negative and I'll deal with it. So 7x minus 7x is 0. So I'm going to bring down the 4 and it's positive. What is negative 9x minus 7x? Negative 16x. Now what? Divide by what? Negative 16. So on the right, negative 16x divided by negative 16 is positive x. On the left, and we're not going to turn this into a decimal, but can you leave a negative in the denominator of a fraction? No. So you either move it next to the fraction bar or to the numerator. It does not matter. So it's going to be negative something. What does 4/16 reduce to? What? 1/4. Because 4 goes into numerator and the denominator. 4 goes into 4 once. 4 goes into 16 4 times. Or you could leave it as a decimal. Either way is okay. Of course, you could check that as well. Anybody have questions on that? Number 16, page 16, example 3. What would y'all think we should do first? Distribute. Make sure you distribute to every term inside the parentheses. So 2 times 3x is 6x. 2 times positive 1. And the right side, there's nothing to distribute, so I'm just going to bring it down. Oh, no. Oh, no. What do we do? Okay. So 6x minus 6x is 0. I'm left with the 2 on the left. On the right, 6x minus 6x is 0, and I'm left with a 14. Does 2 equal 14? No. And there's no x there. So it is no solution. Or no real solution anyway. That means there is no number on this whole entire planet that's a real number that we could substitute in for x that would make the left side of the equation equal the right side of the equation. It's not possible. Ain't gonna happen. Okay?
What's number 4? I don't understand.
I'm getting there. Now, if my x's would have canceled, and say I got 2 equals 2, no variables, but say I got 2 equals 2, does 2 equal 2?
Yeah.
So if that were to happen, that's a true statement. This is a false statement. If all of your variables cancel and you're left with a true statement, then it's not no solution. It's infinitely many solutions. That means you could substitute any number in for x and the left side would equal the right side. Okay? So that's what you write when the left and the right equal each other and there's no variable. No variable and they don't equal each other, no real solution.
Can you combine like terms?
What, you mean like subtract 2? What'd you do first? Tell me.
I was thinking you can combine like terms.
You mean like what?
Just put 6x down.
Well, because they're on different sides of the equation, I can't just add them together. If they were both on the same side, I could. But if they're on different sides, then I have to bring the 6x over here. Since it's positive, I got to subtract it. You know what I'm saying? If they're on the same sign, you wouldn't change the sign. You could just combine them. But since they're not, you got to change the sign to move it over. All right? Example 4, solve the literal equation. So this is just a bunch of variables. You do have one number in there. But it wants you to solve it for r. Okay? So that just means we do the same way we do it with numbers. It's just variables instead of numbers. You do this a lot in geometry when you rearrange formulas and stuff. So right now, like this is a amount in the account, right? Equals principal times 1 plus rate times time. So we know if we want to solve for A, this is how you do it. Well, they're saying get R by itself. So that means if you want to know what the rate is, we'll change the formula. Okay? So you could do this a couple of different ways. You could distribute the P if you wanted to. Or, since P is being multiplied by what's in parentheses, you could divide by what's in parentheses. You could do that. But I think that's going to be confusing because I'm going to end up having to divide again over here to get the R by itself. So I'm probably just going to distribute the P for now and get rid of the parentheses. So what is P times 1? P1 or just 1P or just P. And then I have a positive times a positive. So we got the positive. What is P times RT? PRT. Okay? How can I get rid of this P right here? I subtract it. So A minus P is just A minus P. And I still have a positive PRT on the other side. And I am trying to get R by itself. That PRT means P times R times T. What's it? Divide by what? PT. And I can do that because it's all being multiplied together. So because P divided by P is 1, T divided by T is 1. So that will just leave me with R. On the left side, I can't cancel these P's because I have a binomial and a monomial. You can't just pick out parts. If they were both monomials, like this was, that's a monomial, you can just cancel out certain things. But a binomial can only be canceled with another binomial. So I can't just cancel out those P's. So I literally have A minus P equals P divided by T. I'm sorry, P times T. So if I want to know the rate, I take the amount in the account, subtract the principal, take that and divide it by whatever the principal is times the time in years.
I'll be honest with you, I didn't get that.
Because this is all being multiplied together. This is one term. It's all being multiplied.
Instead of doing it like the longer way you divide by p and then you go back and divide by t, you just went ahead and
You can do it all at the same time. I know literal equations is one of those that a lot of students get hung up on. More that you practice with them, the easier that it is. Okay? So the problem on 17, which we are going to do because it's about credit card statements and how interest is figured. And interest, different credit cards figure interest in different ways. So I'm going to show you the way that the book shows you the interest is figured there. But today, I'm just going to go ahead and give you some examples to do on your own with just equations, okay? Because I want to spend more time on the credit card problem on page 17 tomorrow. And I'm only talking to 5th period right now. So, 5th period, if you will turn to page 18. And I want you to do 1 through 5. You may have enough room in your book, you may not. But you've got to show me your work. And number 5 is very similar to what we just did, except for this time you're solving for t. So go back and look at example 4 to help you. You may have any questions?